See Lindelof videos, graphing y is equal to a sine of omega x. And we're going to explore here what happens if you change omega. So I turned omega here to 2, and I think that this is called a compression. So let's look at what a compression looks like. A compression looks like this. When we're graphing this, what we know is here is that the period is equal to 2 pi over omega. So whatever number is in front of x, you just drop it into this equation. It tells you where the period occurs. So specifically, we have 2 pi, and our omega is that 2 over 2 is equal to pi. That means that this function will go through exactly one cycle every pi. So the distance between here and here is pi, where it's usually 2 pi, so it is a little bit different than what we're used to. So let's take a quick look at what this does. I've said 1,000 times that I see a lot of students, a lot of people who try to graph the points and then graph through the points. I never do that. I just graph this way. So here's my Cartesian plane. I'm only going to graph one cycle. I know that it goes on and on forever from the left to the right, but I'm not going to graph that. All I'm going to do is graph one cycle of it, and I know that one cycle of this should look like this. It should have this general shape, shouldn't it? So all I'm saying is this is its general shape. And this is 0, and this is pi as angular values, which are the x values. Well, if this is pi, and we know that trigonometric functions are symmetrical, then this is half that distance. So I'm going to use the mid-value theorem here, midpoint theorem. So pi plus 0 divided by 2 is pi halves, isn't it? So this is pi halves. That will make this pi fourths, wouldn't it? Make this pi fourths. That will make this 3 pi fourths, and it gives me that value down there. Now I'm going to go and fill these values in, and it's not that difficult, but what you have to remember is this. Our function says sine of 2 times x. So if x is pi fourths, well, 2 times pi fourths is pi halves. So I go look at my unit circle, pi halves, and sine of pi halves is 1. So I go back to this. I'm like, okay, this is pi fourths 1, isn't it? Here I want sine of 2 times pi halves, right? I have this accelerator here that's making this graph more quickly. These things cancel out, don't they? So what is sine of pi? Sine of pi is 0, so this is pi halves 0. Same thing here. Because the way this thing is moving, when I'm at 3 pi fourths, when theta is 3 pi fourths, I have to multiply that always by 2, so I get 3 pi fourths. So really the sine value I get is that of sine of 3 pi. So when I get to 3 pi fourths, I plug the 3 pi fourths into this machine right here. This 2 cancels. This goes to 2. I get the sine value that actually should go with 3 pi halves. So I go to 3 pi halves. This is 3 pi halves. Its sine value is -1. So I go back here, and I can tell this is my -1. And then this is pi 0. So this can be done. One thing you have to actually memorize is you have to memorize this midpoint theorem. And then you have to kind of set this up. I would definitely sketch the curve first. I always sketch the curve first, and then go back and fill in the values. This is a little bit tough because it's weird. Remember that when we're doing the sine curve, because that's what we are doing, sine curve. So sine of x, every point is x sine of x. So when I'm looking for something, if I'm looking for pi at pi 6, then my point would be, look, my point would be pi 6 as an example. And if I had pi 6, the sine value is 1/2. You don't do anything with that cosine value because we're not graphing cosine. So if you said, hey Charlie, how do I graph the point sine of pi thirds? Well, I'd say, okay, that point would be pi thirds, would be the x value. The y value would be sine of pi thirds. Here's pi thirds, and here's sine of pi thirds. So I'd say square root 2 over 2, wouldn't you? All right, you guys, I hope this is helpful. I know that it's kind of a pain, but you can definitely do this, and it's great for you. So keep it up. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. Thanks, you guys.